Okay, so as always, feel free to speak up and ask questions or type them in the chat. Yeah, so you guys are suggesting some stuff to get around this. Yeah, that's kind of, I don't know if I have 2 Zoom accounts. I'll have to look into that. Those are good suggestions. Thank you. All right. So beginning the review. Let's see, the test as of now is going to cover at least 12.1 through 13.2. I posted the video for 13.2 yesterday, the lecture. And if I get 13.3 done and posted by midnight tonight, then that will be on the test as well. So as of now, at the very least, 12.1 through 13.2. Okay. This review, I'm going to just do 12.1 through 12.6. And then in our class on Tuesday, the meeting, since you guys might not have had a chance to look at the lecture materials and all that for 13.1, or excuse me, for 13.2, and assuming I publish at 13.3, we can talk about that on Tuesday, and I'll record that as well. So for this review, I'm just going to go kind of through the sections and kind of tell you what is important from each section. I'm not going to really lecture on, I'm not going to re-teach you guys the material from these sections. That's, in the lecture videos, and you can ask me questions during office hours, and we can definitely go over examples at the end. But for now, I want to go through each section and kind of tell you what I expect from each section, or at least the important stuff. Now, this isn't let's see, how should I say this? This isn't the end all be all of the material. Okay, this is, starting point, and you're really responsible for anything that's in the book or in my lecture videos. More importantly, my lecture videos. If I didn't really cover it, I didn't think it was important, so I'm not going to test you on it, probably. But test is Thursday. Yeah, so I might not have made that clear. Yeah, that's a good question. Test is Thursday. So that means you'll have the opportunity to ask me questions Monday during office hours, Tuesday during class, and Wednesday during office hours. So there's a lot of opportunity to clear up material. So yeah, I'm just going to talk about what's important and what I kind of want to see from you guys. For those of you who were in my classes previously, especially during the summer, this is kind of a similar review as I did over the summer, where I'm just kind of hitting the highlights. But Calc 3 is a bit different, and there's not as much notation, but I'll try and point out notation as I see it. Somebody asked, do we have to take the test during the 8:30 time slot? So my bosses have said, yes, you're supposed to, but I'm gonna see if we can get away with just taking it anytime during the day. So what I've got it set up right now where you can take it at any point on Thursday, and once you start it, you have a 2-hour window. Okay, so that's what it is right now. If I hear anything, different, I'll be sure to let you guys know. As just a safety, if you can keep that time slot free, do so. It is our time, our class time, so the kind of expectation is that you have that time free to complete classwork and things like that. But my plan is to let you take it all day with a 2-hour time limit. If you're an SAS student or have SAS accommodations, just send me an email anytime between now and Wednesday night to remind me to give you a time extension if you qualify for that. If I haven't gotten your SAS paperwork, then I'm not giving you an extension. I think, so I've talked with the people who I know have time extensions. So if we haven't talked about it, you don't have an extension. All right, 12.1. Let's talk about what's important in 12.1. 12.1 is really just introduction, so not a ton here. You should know distance formula. We're going to see later versions of this using dot product in the later sections. We should know the equation of a sphere and the inequality for a ball. So the difference between a ball and a sphere. And let's see if you guys, let's see if I can do this poll. First of all, see if it works. Okay. Does anybody see the poll I've thrown up there? Okay, good. It looks like it's working this time. I don't know what I did differently this time, but it seems people are able to answer. So this is what I mean by you should know the difference between a sphere and a ball. You cannot see the poll. Okay. Yeah, okay, so it's not going to be perfect. Okay. Well, don't worry. I'll kind of, so let's see. As you guys take this poll, what I've written out on the poll is this the equation of a hollow sphere or a solid ball, excuse me. Okay, so I'll end the poll now. Most of you guys said a hollow sphere. That is incorrect. Okay, that's strange that the majority was wrong. X squared plus y squared plus z squared. What is that? That is a solid ball. Okay. This inequality is describing points. Okay. So first of all, if this was an equal sign, what would this be? That would be a sphere with radius 3, right? So centered at the origin. So I'm drawing my horrible sphere. Okay. But since we said less than or equal to, and maybe you guys were tripped up by the inequality, you know, I had to write it out using just a keyboard, so it's kind of lost. So what does this inequality describe? Okay. Think about it like this. This is all the points whose distance is less than or equal to 3 from the origin. Okay, so what would be included in that collection of points? Well, it would be the surface of this thing for sure. Okay, the surface is what we would have if we just had equals. But since we have less than or equal to, we also have all the points inside the ball. Okay, so that's why this is a solid ball. Now somebody, and let's see, somebody said, please clarify, the 9 is the outer edge and the equation is whatever is graphed. I picked the ball based on this option. Yeah. So if it was equal to 9, that would just be the outer edge. Okay. But let's see, what did my poll say? And it didn't even say what is being graphed here. It said, what is this object? What is the object given by the inequality? So when you have it was an inequality for the poll. So when we have that inequality, what we're saying is it's all points that satisfy that inequality. Okay, so it's not just the surface, it's not just the surface of the object, it's everything, all the points inside of it, because all those points inside the ball satisfy the inequality as well. Yeah. So the poll, the notation is a bit bad because it's I had to type it on a keyboard. Not a huge deal, but going forward, just learn the difference and practice the difference between the sphere and the ball. And I think there's some problems. So these are kind of my suggested problems for this section. I think some of those problems will deal with that. Okay, any questions on 12.1? Okay, moving on to 12.2. And by the way, if for those of you who can't see the polls, don't worry about it. You know, I got my attendance poll, so, and I've taken note of the people who couldn't see the poll for attendance, so you know, don't worry about the polls. And somebody asked, okay, Stephanie asked, are these problems from the textbook? Yeah, those are from the textbook. So you all have access to these problems through WebAssign. Access your WebAssign and just click on the ebook. Go to the ebook, and these problems there's problems at the end of every chapter. Okay, you know, maybe I don't know, maybe you guys never look at them because you don't really have occasion to use the ebook very much. But since I have a physical copy of the textbook, you know, I see them all the time as I'm flipping through to your sections. So I don't know. I think they're a great tool. So don't ignore those problems. Okay. Moving on to 12.2. Okay, and this is one of the few things notation-wise I want to point out. 12.2, we start talking about vectors. Make sure you're using, and let's see, pretty much a lot of this test is going to involve vectors, right? In fact, probably the majority, right? So, if not all, it's very important to use proper vector notation. So remember, there's kind of two ways to indicate something's a vector, either with the little vector symbol over it, the little vector arrow, or by doing a bold letter, okay? Well, if you're handwriting stuff, you know, I can't really tell if you're writing a bold letter or if you just have really heavy handwriting, okay? So maybe this is not the best way to indicate a vector. So when you guys handwrite your work for vectors, I want to see your little vector arrow over everything, okay? Over all the vectors, I should say. That's really important, especially, oh God, what do I do? That's really important, especially when we start mixing vectors and scalars, right? So let's say I was trying to do, let's say C is a scalar and V is a vector. Okay. All right. If you just write this, well, I can't tell what's a scalar and what's a vector. Okay. Maybe the default is usually V is a vector and C is a scalar, but that's not good enough, right? I'm gonna, if you've written something out, assume I'm an idiot and I can't tell what you mean. All right. So it's got to be clear to everyone what you're talking about. Okay. So if you're trying to do a scalar C times a vector, you need to write that like this, okay? So there's an arrow over the V indicating that's a vector. There is not an arrow over the C. That means it's a scalar, okay? So this would be the correct version of that. Any questions on that notation? Okay, that's important. We should be able to add vectors graphically, so without using the components, without using the numbers, using this kind of parallelogram law, where if I have, let's say I'm starting with the green and the blue solid vectors u and v. Okay, I use these as two sides of my parallelogram, and I complete my parallelogram. And then these diagonals of the parallelogram, these give me two different quantities, right? Hopefully, I don't know, maybe I'm discriminating against colorblind students. I apologize if you guys are red-green colorblind or whatnot. One way to state it is the longer diagonal of the parallelogram will be u plus v. So this long diagonal going this way, that's my u plus v. And then the short diagonal is going to be u minus v. Right? And how do we get that? Remember that I can basically add tip to tail. So if I wanted to add v to my vector u, I would just kind of move my vector v so its base was at the tip of u. And then, okay, wherever that vector ends, wherever that added vector ends, that's going to be the end point of my vector u plus v. Any confusion there? Yeah, so you can use triangle law instead, but triangle law only gives you u plus v, right? It won't give you u minus v. But u plus v is usually what you need. I would just say, you know, they're pretty much the same thing. If you have the general idea, and this is open book, open notes, so if you know where to find the parallelogram law, you know, if you know the triangle law, you should be good, but you know, keep the parallelogram law in mind as well. Once we introduce the idea of components of a vector, you should be able to do vector addition and scalar multiplication by components. And you should be able to do kind of these they're not super complicated, but these slightly more complicated expressions like this. Okay. Being able to figure that out. So for instance, if I tell you the components of u and v, you should be able to solve, figure out what vectors, you should be able to figure out the components of like 5v minus 3u. Okay. So combining scalar multiplication and vector addition. The length of the vector, okay, that's basically using our distance formula, right? As far as another kind of notation point, you should be able to use this component notation, just filling in the components in the brackets, but you should also be able to write vectors using the I, J, and K notation, this standard basis notation. If you go any further in math, basis vectors are really important. They're usually, maybe not called I, J, and K, but linear algebra, if you guys take linear algebra, you'll be dealing with basis vectors a lot. Very important. So you should be able to convert from one to the other and back. Okay. Should we use the vector sign? I would. Maybe if you write something like this for a vector and you leave off the arrow, I'll take off a point or something. But for I, J, and K, it's pretty clear. If you just want to be extra safe, I would put the little vector sign of the I, J, and K as well, just to make it 100% clear. But maybe I'll, should you use the vector of the hat? So yeah, sometimes you can use this notation as well as a hat for the basis vectors, putting a hat over the I. That I don't really, yeah, so if you want to use that, that's fine. I'll know what you mean. I'll say that's more of a physics thing. Physics has its own interesting notation that seems like it should be the same as the math notation, but is actually not. But yeah, if you want to use hats instead of the arrows, that's fine. You got to give some indication that it's a vector though. And going forward, so we're kind of early on in the section still, but in sections 12.3 and 12.4, we're going to be doing things like cross product, dot product, and so on. And we should be able to do those operations whether we're given the vector in this form or in the standard basis form. Okay, so you need to be able to do everything using both styles of notation going forward, and you should be able to write your answers using both styles of notation. So 12.2, let's see, last thing to talk about in 12.2, unit vectors. Okay, and I believe I have a poll about unit vectors. Let's launch a poll. Let's see how you guys are doing on unit vectors. And for those of you who, forgive me, for those of you who can't see the pole, if I have this vector, what do I multiply this vector by to get a unit vector pointing in the same direction? What number? Oh, and let's see, the options are 1/3, 1/4, 1/5. Okay, that should be enough time. So this is 1/5, and most of you guys got it right. So to find a unit vector pointing in the same direction, what we do is we just find the magnitude of this vector, and then we essentially divide the vector by its own magnitude. So what's the magnitude of this vector? Okay, if I was going to find the magnitude of that vector, the length of that vector, that'd be square root of 3 squared plus 4 squared plus 0 squared. So square root of 25, which is 5. So the magnitude of this vector is 5. If I divide this vector, or you can think of it as scalar, it is scalar multiplication. That might be the more precise way to say it. If I multiply this vector by 1/5, I'm scaling the vector down. I'm chopping its length to 1/5 its original size. So if this vector was originally 5 units long, okay, when I multiply by this, it becomes 1 unit long. It becomes a unit vector. And that's always how we find unit vectors. We just take our original vector and divide it by its own length. What if I wanted to find the unit vector pointing in the opposite direction? Well, I would find the unit vector and then multiply by -1, right? If I add a negative sign to a vector, all it does, so if I have this vector and I multiply by -1, that takes the vector and just points it in the opposite direction. So if I start with u pointing this way, the negative u is the same length, same kind of orientation, but pointing in the opposite direction. Okay. Problems for this section. I've kind of started marking some as basic. Okay, so 2 through 18 are important. You need to be able to do those type of problems, but they're probably too easy to see on the test. 19 through 31, 35, etc. Those will probably be more like what you'll see on the test. Let me just go ahead and turn that section. Look at those problems again. Yeah. Okay, any questions? Okay, moving on to 12.3. Dot product. I'd like you guys to be able to do dot product in n dimensions. So pretty much everything in this course, they always talk about 3 dimensions, R3, but like 99% of this stuff can be done in any dimension. Doesn't matter if it's 1, 2, 3, 15, whatever. So the one exception I would say is cross product. Cross product, you're pretty much only going to see in R3. It kind of gets hairy if you do higher dimension. So don't worry about cross product, but for things like dot product, maybe I'll give you a question that's like, I give you two 5-dimensional vectors and ask you to find the dot product. So what if let's do 4. So if I give you 1, 2, 0, 4, and v is 0, 0, -3, 9. You should be able to find that dot product as well. It's the exact same as 3 dimensions, okay? what do? You multiply the first component by the second component. Okay, 1 times 0. Then you multiply second components together, add them together, add that. Then you multiply third components together. Then you multiply fourth components together. Okay, so all these cancel except 36. And you should be able to do that whether it's 4 dimensions. You know, I'm not going to give you 15 dimensions, but maybe I'll give you 4, 5, 6 dimensions, something like that. It's pretty straightforward. Most of the work will be in 3 dimensions, but keep in mind you can do this stuff in higher dimensions. For dot products, you should know the properties. So there, if you go to, let's see, I gave you most of the properties, I believe, in the lecture, but 12.3. When I say properties, I do this in this section and in the cross product section. In the textbook, in the ebook, there's a table of properties that says properties of the dot product. So review that, know those. I think I did almost all of them in the lecture, if not all of them. And they're pretty basic, but you should know them. Okay, and maybe that will allow you to do something like this easily. Okay, so if this is my A, B, and C, you want to be able to compute 4A dot B plus 4A dot C. Well, by some of those properties, I know I can kind of factor out this 4 from both of those. And then I can add, I can turn this A dot C plus, what is it? A dot B plus A dot C. I can turn that into A dot B plus C. Okay. And that, you know, that simplifies my work a little bit. You could also solve this one just by finding, you know, taking a bit longer route, calculating A dot B, multiplying by 4, calculating A dot C, multiplying by 4, and then adding those two together, okay? But knowing these properties can save you a little bit of work. Okay, so when you come back to this video later, if you want, you can pause here and see what I've done. One of the properties in the table that's very important is being able to find the length using the dot product, right? If I want to find the length of A, okay, that's not going to be A dot A, it's going to be square root of A dot A, right? So this is an important thing to know. I mean, it's important for intuition, okay, especially when we start talking about projection. This identity that A dot B is equal to the magnitude of A times magnitude of B times the cosine of the angle between them. We can use that to find the angle between vectors. And remember, that angle is always we're always gonna interpret that angle to be some angle between 0 and pi, you know, 0 and 180 degrees. It's always gonna be a positive angle. We're always looking for that shortest angle between two vectors. So that's always gonna be, you know, it's not gonna be 270 degrees because it would be easier to say, okay, that's 90 degrees in the opposite direction. Using this identity here, well, not just that identity, but just properties of dot product in general, we should be able to tell when two vectors are orthogonal and when they're parallel and neither. So remember, okay, two vectors are orthogonal if their dot product is equal to 0. They're parallel if this is equal to their magnitude of A times magnitude of B exactly. And it's going to be neither one if we don't have either of these cases. Also remember, okay, they're parallel and pointing in the same direction if we have this equality. If we have this, they're parallel and pointing in opposite directions. Okay. Projections, now I could probably speak for hours about projections. I'll say you should be able to take the projection of from one vector onto another. Be careful not to get it backwards, right? The projection of u onto v is not necessarily the same as projection of v onto u. Okay, so you got to be careful there. I'm more interested in the vector projections. So the textbook makes this distinction between scalar projection and vector projection. I'm more interested in the vector projection. I don't plan to ask you any questions about scalar projections, finding that numerical value. I'm going to ask you to find the vector projection of stuff. Okay, so that's kind of where my priority is. The problems you see here, okay, there's a lot of problems. I'm not saying you have to do all these problems. I've kind of broken these problems down into, or the textbook has broken them down into like groups, right? So maybe 2 through 10 is all the same kind of type of problem. These are all basic, okay? So you don't have to do all of them, but you should do some of them. And then say 15 through 20, they're all kind of the same. So you should at least do some of those, so on and so forth. Any questions, 12.3? Let's see, do I have any other polls? Oh, interpretation of dot product. Well, I kind of gave this away already. I can launch the poll though. Looks like most of you guys got it. If the poll, for those of you who can't see, if dot product of vectors u and v is equal to 0, then the vectors are orthogonal, parallel, or it's impossible to say. They're orthogonal. You should know that, by the test, by the time of the test, you should know that by the back of your hand. 12.4. 12.4 is about cross product, so obviously we got to know the cross product. I haven't written it here, but the whole section is about cross product, so we need that. Right hand rule. Okay, so let's see. I think I have a poll on the right hand rule as well. So let's do this poll real quick. This is a type of question you might see on the test. Kind of a more of a concept thing. Oh yeah, so maybe this is a trick question, right? Not a trick question, but okay. Oh, for those of you who can't see it, what I've given is I've given u is equal to 1, 0, 0. V is equal to 0, 1, 0. Which direction does V cross U point in? V cross U. Let's see, 11, 12. Yeah, so this is, yeah, so a couple of you guys answered U cross V. And this is maybe a good warning for you guys. First of all, let's go ahead and end the poll. Remember, cross product is another one that it doesn't go forwards and backwards, right? A cross B is not the same as B cross A. They're negatives of each other, okay? So you got to be careful what order they give it to you in, right? So we were given V cross U. And now this is one you can, using the right hand rule, compute or figure out mentally. You can figure this problem out mentally. So what direction does this point in? Let's see, if I point my fingers of my right hand in the direction of V, okay, I always put my fingers of my right hand pointing in the direction of the first vector, okay, so V, which is along the y-axis, okay. So let's kind of draw what's going on. Okay, so this is my V. So I point my right hand fingers along this, and then I curl them towards U, so which is pointing this way. Which way is my thumb pointing if I'm doing this with my right hand? There's only one possibility, right? My right hand, and I always take the shortest route, right? So I'm curling them this way. There's only one possible direction for my thumb to be pointing. My thumb has to be pointing down that way, right? So the answer would be negative V direction, or negative Z direction, excuse me. So again, the majority did not get this right, it seems. Let's see. Let me make sure I'm telling you guys the right thing. Let's see, this is the y-axis. So if my fingers are pointing this way of my right hand and I curl them this way, my thumb would be pointing downwards, yeah. So my right hand rule tells me that the cross product should be pointing in the negative Z direction. And we can check this by actually just computing the cross product, right? IJK, okay. This is how I set up my cross product. So let's see, I would have 0I, oops, minus 0J, plus negative 1K. So negative K, and that is pointing in the negative Z direction. Okay, any questions on that? Okay, returning to our notes. Remember that when we take the cross product of two vectors, the result is going to give us a third vector that's orthogonal to both of my original vectors. That property is important. This identity here, that the magnitude of the cross product is magnitudes of our original vectors and the sine of the angle between them. And here we have another way to test if two vectors are parallel. So we can test that using the dot product, right? Or we can use it, test it using the cross product. If they're parallel, their cross product should be what? Should be the zero vector, okay? So we gotta be careful. Cross product is always gonna give us a vector, right? So this isn't the number 0, right? It's the vector 0. What is the vector 0? That's the vector of all zeros. Okay, so that's the 0 vector. So if two vectors are parallel, their cross product gives us this 0 vector. Okay, the problems we should look at. Let's see, there's a fair amount of them. Get our basics. So 1 through 7 is just computing the cross product. 13, yeah, so 13 is kind of like what you saw on the homework. It's asking what's meaningful, what's not. Those are really good to determine whether, you know, I mean, if I give you a problem, you got to know, you should know what to expect for an output. Like if I give you a problem like A dot B, okay, you should know that that output is going to be a number, a scalar. Okay, if I give you A cross B, you should know that output is going to be a vector. And you should know, okay, what is A dot B cross C? What is that going to give me? Well, that's going to give me a scalar too, right? This is going to give me a vector. And then I have a vector dot a vector. That gives me a scalar. So the output of this whole thing is going to be a scalar. You should be able to look at a problem and kind of know what output to expect and whether that makes sense or not. So 13 is good, 14, 15, 16 is right hand rule. '19 through 20. And again, these are not the only problems to practice, but these would be a good start. 22 is kind of a concept thing. So 22 is interesting. It says, show that A dot B cross B, or dot B, A cross B dot B is equal to the number 0 for all A and B in V3. V3 being all the vectors in R3. Okay, this is an interesting problem. I would definitely consider giving you something like this. Okay, so what do I mean by show? Well, how would you do that? You could start by letting A equal A1, A2, A3, and B equal B1, B2, B3, just kind of leave it in this general notation, and then compute this thing and show it equals 0, okay? So I wouldn't call this a proof, but it's a nice little exercise, okay? 12.5, any questions on 12.4? Okay, I think I'm out of polls, so no more polls. 12.5, lines, line segments, planes. Okay, we should be able to find equations for all of those. We should be able to write them in vector and parametric notation. I'm not going to tell you how to, or I'm not, well, I might tell you how to write the answer. I might tell you, okay, write your answer in vector notation, write it in parametric notation, something like that. So you should be able to do both. An example, you need to be able to do write equations for lines and line segments. So remember, for lines, your parameter can range between positive infinity and negative infinity. For a line segment, maybe your t only ranges between 0 and 1. Okay, so be able to work with that. For planes, there's several ways to find equations for planes. We can find an equation of the plane if we're given a vector in the plane and a normal vector, or 2 points in the plane and a normal vector, or just 3 points in the plane. Okay, so no, there's no more polls. Somebody asked if there's more polls. No more polls. So how do we find the cross product? Or how do we find the equation of the plane if we're just given 3 points in the plane? We use the cross product, right? If I'm given 3 points in the plane, well, this can give me 2 vectors, right? I can think, let's call this P arrow. How about Q, R, and P? Okay. Let's see. Can you guys still see my screen? And just give me a weird message. Okay, you can still see it. Let's see. Is it still updating though? Because I'm kind of drawing squiggles and it looks like they're not showing up. I think I got kicked out of my iPad. Let's see. See, now it gave me my polling error message. Okay, so maybe I lost all the data for those polls. Oh well. Okay. So if we're given 3 points in the plane, how do we find the equation of the plane? Well, I make one vector from P and Q. I make another vector from P and R. I take their cross product. That's going to give me a vector normal to both of those vectors. That's going to be a vector normal to the plane. So now I got my normal vector, and now I have a vector in the plane as well. Like I could use PQ. I could use those two objects to make an equation of the plane. Okay, so we should be able to make equations of the plane from any of those three starting points. Plane relationships are kind of determined by what's going on with their normal vectors. What I mean is, if I have two planes, the two planes are parallel if their normal vectors are parallel. They're perpendicular if their normal vectors are perpendicular. So planes are just completely determined by their normal vectors as far as you're concerned. Problems. I don't think there's a ton to do in 12.5. It's, you know, fairly straightforward, I think. 12.6, and this is kind of all I prepared for this session. We can talk about chapter 13 on Tuesday, or continue when you guys finish this. Oh, yeah, 6 through 18. All right. Cylinders, remember that's when one component is missing. What I mean is, okay, if you have the equation like x squared plus y squared equals 9. Well, in R2, that's a circle. What is this in R3? It's a cylinder, right? This is a circle in the xy plane. And then since there's no z coordinate specified, it just goes up and down forever. So that's a cylinder. And in general, okay, if one component is missing, that should be a cylinder in R3. Remember, we have this kind of general definition for a cylinder. So if I had like y equals x squared in R3, that would look like what? This. Okay, something like that. That goes up and down forever. So you should be able to draw cylinders. Really, it's just about, cylinders are just about figuring out which direction the two-dimensional shape should go, right? Quadratic surfaces, see the table in 12.6. That table's very helpful. Table 1, that's in the ebook. Check that out. That's just incredibly helpful. It really gives intuition on what you're trying to draw. There will be some drawing. Yeah, you know, you need to be able to sketch some surfaces. I said table 1 minus the hyperbolic paraboloid. So I don't think I'm going to give you a hyperbolic paraboloid to draw, that saddle shape, just because I feel bad making you draw it if I can't draw it for crap. And if you can't draw it, then it's going to be kind of hard to grade. You know, it's if you just give me some mess of lines and parabolas and hyperbolas, it's going to be hard to grade. So I'm going to give you, you know, I think all the other 5 shapes in that table are kind of up for grabs. The ellipsoid, which would include circles and spheres, cone, elliptic paraboloid, hyperboloid of 1 sheet, and hyperboloid of 2 sheets. Those are all up for grabs. The only thing I'm not planning on asking you about is, I'll say this, I'm not going to ask you to draw the hyperbolic paraboloid. Maybe I'll give you an equation and ask you what type of shape it is, and you have to tell me, okay, it's the hyperbolic paraboloid, but I'm not going to ask you to draw it. I don't think there's too much to 12.6 other than drawing those shapes. So it's just about knowing your level curve, or being able to draw your, I call them level curves, traces, being able to draw your traces and figuring out how to put them together. Okay. Let's see, problems from 12.6. I would say anything up through 38. And how about some problems about the intersection of regions? Did they give us any of those? Not ones I want to give you. Is that in 13.1? Yeah, okay, that was in 13.1. I'm thinking of 13.1. Okay, so now let's stop for my lecture, and somebody's already asked a question, and let's use the rest of the time for questions on 12.1 through 12.6, and then Tuesday we can talk about 13.1 through 13.3, depending on if I publish 13.3 tonight. Okay, so can we go over the 3 points plane problem again? What do you do after getting the cross product? Okay, so let's do an example real quick. We can do a quick definite example. Let's say I have the point P, let's say that's 1, 1, 4. Q is 0, 1, 5. R is negative 1, 1. 0. Okay. Let's find the equation of the plane that contains all 3 of those points. Well, if we want, we can, draw a picture, try and get an idea of what's going on. Okay, 1, 1, 4. That'd be like 1, 1. Maybe up here. Okay. 0, 1, 5. Okay, 1. It's pretty close to it. It's just kind of there. And then negative 1, 1, 0. So that's just kind of an XY plane. Okay. So the plane probably looks something like this, kind of going down steeply. Well, I've just erased everything. Okay. It would look something like this, kind of a steep plane. Okay. All right. So we want to find the equation of that plane. Okay. And let's just kind of draw a rough idea of what's going on. We have these 3 points that are roughly like this, oriented like this. That's P, that's Q, that's R. Okay. So how can we do this? We need to find a normal vector, right? So that's our first step. So let's find a normal vector. Okay, so let's first determine what the vector PQ is. Okay. PQ, how do I find the vector PQ? I take the endpoints, or I take the points of the coordinates, the components of Q, and subtract away the coordinates of P. Okay, so that'd be 0 minus 1, so -1. That'd be 1 minus 1, so 0, and 5 minus 4, 1. Okay, so that's the vector PQ. Now let's find the vector PR. I do the same thing, PR. Okay, that's -1 minus 1, so -2, 1 minus 1, so 0, 0 minus 4, -4. Okay, that's my vector PR. Okay, now I want to find a third vector that's orthogonal to both of those. So what do? I take the cross product of PQ and PR. And now this, you know, depending on if we do PQ cross PR or vice versa, that's going to give us 2 different answers, but either one should work. Okay, so maybe you'll get different numerical answers from your classmates, but they'll both be correct. Okay, so let's do PQ cross PR. Okay, I set up my cross product. Okay, so let's see, I would have 0i, right? Minus, j, well, jb. Let's see, I cross this out. I get +4 plus 2, 6, so minus 6j. And you guys feel free to correct me if I'm wrong. And then what's my k coordinate? Looks like 0. Okay, so really this normal vector is just 0, -6, 0. Okay, now if we had done the other direction, the other PR cross PQ, we would have gotten +6. Either one would work. So we have a normal vector. So let's call this n. Okay. Now I have a plane and a normal vector. Okay. Remember, a plane is going to be the vector equation for a plane is what? N dot r equals 0, where r is some vector x, y, z. And actually, it's a vector in the plane, right? So this should be r, yeah, exactly, Stephanie, thank you. R minus r0. Okay. So what we need is n. So let's assume r is a point xy0, or a vector xy0, or excuse me, xyz. And then r sub 0 is a point, is a vector whose endpoint we know is in the plane. So for example, we could use, let's see, any one of these points. Okay, so let's say r0 is p. Okay, so it's the vector that starts at the origin whose endpoint is at p. Now I have all the information I need to write my equation, right? My r is just going to be x, y, z. My r0 is just one of my points in the plane turned into a vector. And then I found my normal vector, right? I found my n. Okay. So now what is n? N is this. So now let's just go ahead and write it out. If I tell explicitly what n, r, and r0 are, okay, then I can just say, well, my equation of the plane is just this. Okay, this thing. So all of this information together would satisfy as a solution. Or what we could do is write it out in the kind of more parametric form, more explicit form. We could say, okay, what was it? N 0, negative 6, 0. Okay. X minus 1, y minus 1, z minus 4. Okay. So all I've done is I've subtracted r0 from r, and I'm taking this dot product. And then I'm just expanding this equation. Well, 0 times x minus 1 minus 6 times y minus 1 plus 0 times z minus 4 equals 0. So negative 6 times y minus 1 equals 0. Okay, so that's my plane. So negative 6y plus 6 equals 0. So negative 6y equals negative 6. In other words, y equals 1. So any of these would be acceptable solutions as well. Why can't you use PR, P0, PQ, or PR? We want variables. We want variables X, Y, and Z in our equation for the plane. So we want, we found our normal vector. The plane, remember, the plane is all the points X, Y, and Z that satisfy like, X, Y, Z minus what? 1, 1, 4, was that one of the points? I want to be able to write all the points X, Y, and Z that satisfy this equation. If I just had N and I use like PQ for my R minus R0, all that tells me is that this vector is orthogonal to that. That doesn't really describe a plane. That just tells me, okay, this vector N is orthogonal to PQ. I need something that involves X, Y, and Z. So I leave R as X, Y, and Z, and then I subtract one of those points in the plane. And this will be a point in the plane, right? If I tell you what X, Y, and Z are, and that point is on the plane, then this point minus that point is in the plane. Okay, so it's like PQ or PR, but in more general form.
Okay. So you can't use PR or PQ for R of 0?
No. Let's see. X. No, because if R is the vector X, Y, Z. Okay. Okay, so let's say that's our plane. And let's say R is the vector whose endpoint is on the plane. Okay, so that's R. And then we use R, let's say this is P. Let's say this is PQ. use PQ. If we did R minus PQ. I guess we could actually, because let's see, PQ, no, we can't. PQ, so PQ would be like a vector. If we put PQ starting at the origin, it'd be like pointing that way. So R minus PQ would take us off the plane, probably. Maybe not in all cases, but it probably would take us off the plane. So use a point on the plane. Yeah, and that's what Brandon has said. Yeah. So that's the reasoning there. If we use PQ, it would, you know, R minus PQ would take us off the plane. Yeah. Any other questions on that? Okay, so I believe somebody asked for a projection problem. By the way, let's see, STEM seminar ends at 5:50, right? Yes. Okay, so we are now at the end of STEM seminar. So if you guys want, you know, whoever wants to leave can leave. And I will pass along the attendance to Ariel. And I'll keep answering questions for whoever wants to stay. All right, projection. So projection is what, 12.3? Okay, so let's first just do a numerical example. So let's use these vectors in R2. And the notation they use, okay, if I want to project B onto A. And this is pretty standard notation. I can never remember, and I can never keep it straight. But the projection of B onto A is this. Okay. So think of this subscript here as kind of your base or your target. So I want to use this. Okay. I'm going to use this formula. The projection of B onto A is what? A dot B over magnitude A. Well, you could use this. I use a slightly different formula. A over magnitude of A. Okay. And then notice these magnitudes of A. Okay, we can combine those and they become A dot B over magnitude of A squared. Okay. Now remember what magnitude of A squared is. That's the same thing as A dot B over A dot A. Okay. So there's a lot of A's. so this is our formula. It's basically one product divided, one dot product divided by another times the vector. Okay. So using this formula, let's try our dot product, our projection of B onto A. First thing I need to do, okay, so I need to find A dot B over A dot A. Okay. So what's A dot B? Well, A dot B would be -5 times 4, so -20. 12 times 6, so plus 72. Okay, what's A dot A? That'd be 25 plus 144, so it's what, 169? And then I have my vector A. So this is just a number, this is just a scalar. Okay, so that. And then I could just take this scalar inside my vector, right? A is the vector -5, 12. Okay. Well, I could just multiply this stuff out. -5 times 52 over 169 times 12 times 52 over 169. I could simplify that. If you're giving me an answer on the test, you know, this would be acceptable. You wouldn't have to simplify that farther. Okay. Projections, let's see, projections have a lot of applications. Let's see if they ask about any projections here. Applications. Yeah, so let's see, they do maybe some force. I'm not going to give you any word problem for projections, though, I don't think. I think the last problem I told you guys to look at was maybe 45. I think that should be far enough. Any further questions on projections or any other topic? Okay. So just some general guidelines for the test, like has been announced already. It's open book, open notes. So as you study, you know, I'm a big believer in notes and note cards. I use note cards all the time myself. Notes in general, you know, it's a good way to, you know, organizing your notes is kind of a good way to organize your thoughts. So I'm a big believer in making notes as you study, and make them, go ahead and make them up in advance. And that way, when you start the test, you know, and the clock's running, okay, and you find a problem and you say, oh, I need to look at my notes for this section. Okay. If you've made up the notes in advance, you know where that material is, where to find it. You know, you've already gone through the trouble of writing it down. So you kind of you can find it more quickly. It's at your fingertips. If you don't make that stuff in advance, if you just kind of study, you know, that's great. You know, do whatever you want as far as studying. But okay, if you just kind of read the book and watch the videos and all that, maybe you'll find a problem on the test and say, oh, what section was that in? That was in like 12.3, 12.4. And then you got to go, you know, clicking through the book if you're on the ebook and trying to go page by page. And I don't know if you've used the ebook, but it's a little cumbersome. It's not easy to flip through quickly. Okay, so take that into consideration on the test. There is a time limit on the test, so maybe you can't afford that time. So make out your notes in advance. I would say it's going to help organize your thoughts, and I think it'll be quicker than just relying on the book. That being said, I'm done, so you guys can start signing off. And if you want to stick around and ask questions to a smaller crowd, you can. I'll log out in a couple minutes if there's no further questions.